11.2 representing outcomes. I can use tree diagrams to represent outcomes.
Thank you, Nor. Can you all use tree diagrams to represent outcomes?
Yeah!
I know this is the second day of the lesson, but what do we call all possible outcomes?
Sample space.
Sample space. So when we're looking at all of the different outcomes, we're talking about the sample space, and it even says right there, all possible outcomes. Now, what is a tree diagram? It's a visual, a picture. Helps us organize data. What's an outcome? The answer, right? Cheat sheet says draw pictures. Fundamental counting principle. Can somebody tell me the formula for the fundamental counting principle? Boys, can you sit down, please? Abarami?
You multiply the first set times second set and so on.
Good. And it says right there in the cheat sheet. The fundamental counting principle, you take the first set, you multiply it by the second set of results, by the third set of results, and so on. So if I'm flipping a coin, what are the number of possibilities on a coin flip?
2.
If I flip a coin 3 times, I would take the possibilities in the first set, which would be 2. What would be the possibilities in the second set? What would be the possibilities in the third set? What's 2 times 2 times 2? 2 times 2 times 2? Can you imagine if you did 2 times 2 times 2 and got 6, how frustrated you would be on your MCA test or your NWA test or any test if you got the fundamental counting principle idea correct, but you couldn't multiply 2 times 2 times 2. Wouldn't that be a bummer? Yeah, so be careful. Always double check your work. All right, number 5 is a great example. How many outcomes are possible if you spin a spinner below twice? Well, if you spin the spinner the first time, how many possible outcomes would there be on this spinner?
4.
If you spin it the second time, how many possible outcomes would there be?
4.
What's 4 times 4?
16.
16. Okay, number A, or letter A, just goes on a little bit further and says, what's the probability of getting an A and then a D? The fundamental counting principle said, well, you get 1. You have a 1/4 chance to get an A, right? And you have a 1/4 chance of getting a D, right? What's 1/4 times 1/4?
1/16.
1/16. And then what we did is we went down and we made a tree diagram. Don't say anything mean because you're on video right now. Mrs. Klein-Saucer's here, just so you remember.
Hi, everyone.
So we made a tree diagram. Yes, no?
Yeah.
Can you guys wait until we finish this video, Grace and Isaac? Chill out for just a second. And we found that A and D happened 1 out of how many times? Well, what our fundamental counting principles say?
1.
Out of how many?
16.
16. So we proved it using our tree diagram, right? It
Yep.
happened 1 out of,
16.
and those are all of our possibilities. And then your cheat sheet down on number 3, when we talk more about creating tree diagrams, eyes up here, please. It says check the tree diagram answer with the fundamental counting principle. If you check both and they match up, you're 100% guaranteed of getting it correct, correct?
Correct.
Awesome. I am not going to spend a whole lot of time on the tree diagram since we just did one, but if you can do the tree diagram and the fundamental counting principle together and they match up, you're golden. And again, I'm going to repeat this. If you get this, or if you can work through your assignment on this and get this, the MCA test will be a breeze for you. This is a huge part of it, and if this is something, and I think most of you already confirmed to me you're getting this, you're going to be not dealing with passing, you're going to be dealing with how much you're going to pass by, right? Cool, cool, cool. Definitely pay attention to these. We have a couple more examples. Good luck.